I want to work another problem involving a force applied at an angle. You do this when you mow the lawn, at least if you actually push the mower. If you have one of those self-propelled automatic drive things, that's not the case. But if you're actually pushing the lawnmower, you're exerting, let's say, 50 newtons of force downward at a 60-degree angle above the horizontal, well, not above the horizontal, but a 60-degree angle on a 20-degree or a 20-kilogram lawnmower. And in this problem, it says the lawnmower is moving at a constant velocity. That is an important phrase. Whenever you see it, you should probably circle it. It's very important to know for later on. We want to find the normal force and the force of sliding friction. All right, the first thing we have to do in this case is to, again, resolve the vector into x and y components. That's the first thing you do whenever you're given an angle and anything else, a force or a velocity. So we have a 50 Newton force down at a 60-degree angle like it's shown here. If we're going to use our shortcuts where we do F cosine theta and F sine theta, the only way to do that is to put the x component on the x-axis. Okay, so this is our axis that we can imagine. That's the x component, that's the y component, which means we may have to do a little bit of geometry work here and imagine that this is a rectangle which we've just bisected, and if this angle is 60 degrees, we can reason that this one is 60 as well, which means that our work is the same, but we need to make sure that what we're doing is actually correct, because this is a little bit different than what we've normally done. So the x component is 50 cosine 60, and the y component 50 sine 60. And if you calculate those out, you'll find your x component to be 25 newtons, and the y component is 43.3. And again, we need to look at the at the picture we drew and look at the direction. X is going to the right, so that'll be positive for the x component. But y component this time is coming down, so that means that our y component will be negative. Very important to remember. Alright, so I found x and the y components. I'm now going to get rid of the original force and angle. Do not use those again. So for part A, they want to solve for the normal force. And to do that, I have to, once again, I have to sum the forces in the y direction. Alright, so all the forces in the y, well, perhaps I should draw a free body diagram first. That would be a good idea, wouldn't it? I've got the force of gravity, the normal force, and I know I have a frictional force because they asked me to solve for it. And then I'll put my two x and y component over here. X is positive, going to the right, and y is negative, so it doesn't go up this time, it comes down. And there's our free body diagram. So now I can easily look at what forces are going on in the y direction, and it's these three: normal force plus gravity plus the y force, and those have to equal 0. We're on a surface. The acceleration in the y direction is 0. In case you haven't figured out by now, to sum the forces in the y direction, at least in this class, it'll pretty much always be these three forces. I know the y force. They're asking me to find the normal force. I don't know the force of gravity yet, but I can find it real quick by doing Fg equals mg. Mass being 20, which is what they gave me, and the acceleration of gravity is 9.8, which gives me a force of gravity of 196 newtons. And in my equation, that had better be negative because force of gravity is directed downward. So now I can start plugging in numbers. Normal force plus negative 196 plus the Fy is also negative 43.3. That has to add to 0. 43.3 plus 196 will add together, and they'll be negative since they're the same sign. And we get Fn minus 239.3 equals 0. And if you add 239.3 to both sides, which I know may seem elementary, but it's what we're doing, and I'm just making sure everybody's on the same page. That gives us a normal force of 239.3 newtons. Again, different from the force of gravity. The next one asks us to find the force of sliding friction. So that's the force of kinetic friction, in other words. And you might think, okay, well, we need to use the fun equation to find the force of friction, right? Well, it's a good idea. Unfortunately, it doesn't work because we don't have the coefficient of friction. They didn't give it to us. If you're reading the problem, remember what I said. If they give you the coefficient of friction or they ask you for it, that's when you'll use this equation. But if neither one of those is true, that's not what we'll use. So you have to use some other logic. Well, remember we circled or underlined or whatever this phrase, constant velocity. Constant velocity means the acceleration is 0 in the horizontal direction. And the only way for the acceleration to be 0 is if the forces are balanced. And now it becomes real easy. That means these forces in the x direction have to be balanced if we're moving at a constant velocity in the x direction. That means whatever I have here has to equal the frictional force on the other side. Since I've already found the x force, 25 newtons, that means I can assume, not assume, I know that the force of kinetic friction is also 25 newtons, and it's negative because it's directed to the left. I'll leave number 2 for you at the bottom, and if you're going to do it, you should change this one to 0.3. We did that in class. It works out a little bit better. Let's do number 3 on the back. Ninja is dragging a cart of weapons across the floor with a force of 200 newtons at a 45-degree angle. If the weight of the weapons is 490 newtons and the floor is frictionless, probably an important thing to know. Again, find the normal force and the horizontal acceleration. So here we go. First thing we need to do is resolve the vector. 200 newtons, 45 degrees, x component, y component. The x component is found by doing 200 cosine 45, and the y component 200 sine 45, and you'll actually find that you get the same number out of both of those because that's what happens when you have a 45-degree angle. The two sides of the triangle have equal lengths, and you get 141.4 newtons. Looking at our picture, both of those are positive, which makes it a little bit easier. Cross out the original force and angle. Draw your free body diagram. Gravitational force, normal force. No friction this time. Floor is frictionless. Got nothing on this side. But I do have my y force and my x force. There's the free body diagram we have this time. To solve for the normal force, I will still sum the forces in the y direction. Normal force plus y force plus the gravitational force. And if we're on a surface, the sum of the forces must be 0. Now, the interesting thing about this one is they've already given us the gravitational force. It said the weight of the weapons is 490 newtons. The weight is the force of gravity. So that makes this particular part a little bit easier because we already have everything we need. Normal force plus the y force, which we found to be positive 141.4, plus the force of gravity, which is 490, but it is negative because gravity is directed downward. Add 490 to both sides, you get normal force plus 141.4 equals 490. Subtract 141.4, and you'll find that normal force is 348.6 newtons. There's your normal force. Not equal to the force of gravity. Check. So there's part A. Part B, we want to find the horizontal acceleration. If we're messing with acceleration and we don't have any speeds, we're probably going to be using sigma F equals ma. And I'm going to sum the forces on the left side that are in the direction of my acceleration. Acceleration is horizontal. So I'm going to sum all of the horizontal forces, and it's beautiful this time because I just have one. There's no friction to consider. So the x force equals the mass times the acceleration. I know this, but I don't know the mass. You might be saying, wait, mass is 490. No, it's not. The weight is 490, and weight does not equal mass. They're not the same thing. So you say, well, how do I get the mass? Well, they did give me the weight, and I know that the weight, or the force of gravity, equals the mass times the gravity. So I can use this equation to solve for the mass. Negative 490 equals mass times negative 9.8. Divide by negative 9.8. And that gives me a mass of 50 kilograms exactly. So now we can plug that into here. X force is 141.4 positive, and that equals 50 times the acceleration. Divide both sides by 50, and you will get an acceleration of about 2.8 meters per second squared.